Hello everyone, I am Sri Krishna Gosavi, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Today we are going to discuss on a topic force and system of forces. The learning outcome of this topic is at the end of this session the student will be able to categorize a given system of force as a concurrent, non-concurrent, coplanar or non-co. So first we will start from the engineering mechanics. What is engineering mechanics? So engineering mechanics, it is a branch of science which deals with the forces and their effects on a body in a motion or at rest. Basically in the engineering mechanics we studied the rigid bodies. So in the rigid bodies are the bodies on which there is no deformation or their shape and size will not hampered under the action of the load. So those bodies are the rigid bodies. So those rigid bodies mainly we are going to study in the engineering mechanics. So it comes under the science and it deals with the forces and their effects. And body maybe it is stationary or it is in the motion. All these things are comes under the engineering mechanics. So engineering mechanics is again subdivided into two categories, statics and dynamics. Statics is not further divided, but the dynamics is again divided into two categories, kinetics and kinematics. Now one by one we will see the information about these all branches. So now first is the statics. So what is statics? So it is the branch of engineering mechanics which deals with the study of the forces and their effects on a body at rest. So when the body is stationary, body is not moving, then at that time whatever the effect of the forces acting on the body and the effect of the force on that body, it is studied under this branch, that is statics. It comes under statics and it is the branch of engineering mechanics. Next is the dynamics. So dynamics, it is again the branch of engineering mechanics which again deals with the forces and their effects on the body, but now the body is in the motion. So the definition of the dynamics will be, it is the branch of engineering mechanics which deals with the study of forces and their effects on a body in a motion. Next, dynamics is subdivided into two categories, kinetics and kinematics. So it is the branch, kinetics means what? It is the branch of dynamics which deals with study of forces and their effects on a body in a motion, considering mass of the body and forces causing the motion. Similarly, kinematic means it is the branch of dynamics which deals with the study of forces and their effects on a body in a motion, but here without considering the mass of the body and force causing the motion. So this is the basic information about all the sub branches of the engineering mechanics, how it is getting divided. Now we will move further. And now scalar quantities. So what do you mean by scalar quantities? So scalar quantities are the physical quantities which needs only the magnitude, but no direction is required to define them. So for example, mass, distance, area, volume, time, etc. All these are the scalar quantities where though these quantities can be defined by using magnitude alone. The direction is not required. Similarly, vector quantities. So vector quantities are the quantities in which magnitude is required as well as direction is also required to define that quantity. So it is a physical quantity which is having both magnitude as well as direction is known as vector quantities. Example, weight, force, velocity, acceleration, etc. Now force. What is force? So force is defined as an external agency which may be push or pull, which changes or tends to change the state of rest or uniform motion of the body under the upon which it is act. So a body, suppose it is at the stationary condition, and if the force is applied on the body, it may start moving, it may start moving suddenly, or under the application of the force it starts moving. So when the body is initially stationary, after the application of force it starts moving. So this is nothing but the change of state of the body from rest to motion. It is happened due to force, and force is applied externally. So it is says that it is defined as the external agency. Okay, and this force will changes or tends to change the state of rest or uniform motion of the body upon which it acts. So the unit of force is Newton or kilonewton. So this is the pictorial view how the force is applied. Here you can see a person who is pushing this box. This is where he has applying the pressure here. This is the point of application. This is just a pictorial view for the understanding of the force. Then characteristics of force. So there are four major characteristics, basic characteristics of the force. First is the magnitude. Magnitude is nothing but it is the quantity of the force. These are required to define a force. So that is why we called it as the property of the force or characteristics of the force. Then second is the direction. So the line along which the force acts, it is also called as the line of action. Then point of application. So the point at which the force is applied is called as point of application. Then nature of force. So the force may be a compressive force or tensile force. So it is classified as push and pull. So push means compressive force and pull means tensile force. So now push or compressive force. So here see, this is the surface. On this surface a body is kept and now force is applied. Let us say F is the force is applied on the body. So now this is the line of action of the force and this is the point of contact where the force is acting. Now here you can see this arrowhead of the force is acting towards the point of contact. So this this is nothing but the push type of force, or this is called as compressive force. So here we can see if the arrowhead is pointed towards the point of application, then the nature of force is push. It is also called as a compressive force. Then pull, tensile force. So similarly the body, again the same body, if we see F force is applied on the body, this is the line of action of the force and then this is the point of contact here. And now here you can see the difference that the force is acting away from the point of contact. So if the arrowhead is pointed away from the point of application, then the nature of force is pull and it is also called as a tensile force. Now the system of forces. So what is the system of forces? Basically what is the system? When two or more forces are acting on any object or any body, then we called it as a system. For a single force we won't call it as a system. At least the force must be two or more than two forces are acting on any of the body or any on the rigid body, elastic body, two forces or more than two forces. Then we called it as a system. Now system of forces. So system of forces are further divided into subcategories. Classifications are there that we will see first. So the system of forces basically divided into two categories: coplanar forces and non-coplanar forces. So non-coplanar forces are not further divided, but the coplanar forces are divided again into four categories: collinear forces, concurrent forces, non-concurrent forces and parallel forces. Parallel forces are again divided into two categories: like parallel and unlike parallel forces. So now coplanar forces. So as the name suggests that coplanar forces or coplanar forces means the forces which lies in the same plane. It is called as the coplanar forces. So here you can see x, y, z are the three mutually perpendicular axes. Let us say F1 it is lying in xy plane, F2 it is also lying in the xy plane, xy plane. F3 is also lying in the xy plane. So all these three forces F1, F2 and F3 are lying in xy plane only. So these forces are called as the coplanar forces. So here you can say when the number of forces are acting in the same plane, then the forces are called as coplanar forces. Now non-coplanar forces. So non-coplanar forces, again x, y, z are the three mutually perpendicular axes. Now here you can see F1 force is acting in the xz plane, F2 force is acting in xy plane and F3 force is acting in yz plane. So here all these three forces are acting in three different planes. So this type of force system is called as non-coplanar forces. So here when the number of forces are acting in a different plane, then the forces are called as non-coplanar forces. Now coplanar forces again divided into four categories. So first is collinear forces. So here you can see these three forces F1, F2 and F3, they are acting on the same line of action. The line of action of F1 coincides with line of action of F2 coincides with line of action of F3. So this is called as collinear forces. Similarly, F4, F5, F6, these are also collinear forces. The line of action is matching. So when a number of forces are acting in the same line of action, then the forces are called as collinear forces. Similarly, concurrent forces. Concurrent forces means, let us say this is the point on which F1 force is acting, F2 is also acting over here, F3 is also acting on the same point, and F4 is also acting on the same point. So on a single point, if multiple forces are acting, then this type of force system is called as the concurrent force system. So we can say that when the number of forces are acting at the same point, then the forces are called as concurrent forces. Non-concurrent forces, now you can see this is point A. So on point A, F1 force is acting. This is point B. On point B, F3 is acting. This is point C. On this point, F2 is acting. Now here you can see all the three forces F1, F2 and F3 are acting on point A, C and B respectively. So three forces are acting on three different points. It is not acting on the same point. So this type of force system is called as non-concurrent forces. So if the forces lies in the same plane but acting at the different points are called as non-concurrent forces. Parallel forces. The forces whose lines of actions are parallel to each other are called as the parallel forces. So like parallel. So these are the examples of the like parallel. Here you can see F1, F2, F3. The lines of actions of all these three are parallel to each other and they are in the same direction. Similarly this example, similarly this also. So in the like parallel, the parallel forces which are acting in the same direction are called as like parallel forces. Unlike parallel forces, so here you can see F1, F2, F3. All the three forces are parallel, but F1 and F3 are acting in one direction and F2 is acting in the opposite direction to them. So this type of force system is called as unlike parallel forces. So here also you can see F1, F2 in the same direction, F3 is in opposite direction. Here F2, F3 is in the same direction, F1 is in the opposite direction. So here you can say the parallel forces which are acting in a different direction are called as unlike parallel forces. The forces are parallel but they are acting in the opposite direction or different direction, we can say. So this is the system of forces what we have seen, and these are the references I have taken for this session. These are some good books I am showing over here, and thank you.